Hello, this is Sawyer McLean, and hopefully I'll be facing the camera here for part 2 of our Python tutorial. So as you can see right now, we're back in our Python interpreter on REUPLOADED, and we're going to go over some functions real quick, just to get kind of a sense of what Python can do, and then we're going to write an actual function of our own and compare that to what it would look like in C. So I think in the last video I showed that we can essentially start adding and adding strings together like we would any other number. We essentially have like a little calculator thing going on in here. Hello plus space plus world. Hello world comes out, so that's pretty good. Now, if we write that over here, we're gonna in an actual Python file that we were gonna run. Let's go ahead and try that. I'll just copy it over. Hello plus world. That's not it. File. Hello plus world. So if we run that, nothing happens. That's weird. Why is nothing coming out? Well, over here in our interpreter, we have something what's called a read, evaluate, print loop. Essentially, it does a little bit more than the standard calculator kind of input. Just what it does, it reads in a statement, evaluates that statement, and then prints out the result. So the print statement over here is implicit. So writing print hello is the same as just writing hello. Now, we can do the same. What we've got so far isn't really interesting. Sure, we can play around with strings and stuff, but I mean, we can do that in Microsoft Word. What's the big deal here? Well, things are going to start to get a little bit more impressive when we can start creating variables. So, what are variables? Same thing as what you probably learned in algebra. It's a certain thing like x that can be anything. So in this case, we can say x equals hello, and if we type x out again, we get hello. So we've created a variable of x, and check the type of x, it's a string, and it holds the value hello. We can change that, x equals world. X, it's now world. And we can do the same thing, say x equals 5, x now holds 5. So basically in Python, variables are just containers that will hold these values. And as we can see, we're going to see later on, we're not just going to have numbers and strings, but we're going to be able to make our own types and make types out of those types. And it's going to get a lot more, complicated, but that's where a lot of the power of programming comes from. Here, let's fix this first. Now if we run it, hello world, there it is. So over in the Python file, this is not going to be running in it basically is just going to be a read evaluate loop. So this string on its own evaluates to hello plus world, but it doesn't print anything. We actually have to tell the computer, hey, I want to print this out. I want to see this on the screen. So what we're going to do now is we're going to create a program that's we're going to just find a way to take the max of two numbers. Now, both languages that we're going to use have this built in already, but it's a really simple example, and it'll show us a way that we can start using with what are called logical statements to build our program up and actually do some interesting computation. So let's start out in Python over here. We're going to say print, please enter two numbers. Now, whoops, we're actually going to do input x, y equals input, enter two numbers. And then we're going to split that. And what that's going to do is split it by a space. So if we do that right now, and then print out x and y. So say enter two numbers in a sec. So we'll say their number is 15 and 12, and we'll get 15 and 12 back out. So x and y have now stored those values that have gotten split. That's essentially what that comma does, is changes this into a list. So what we're going to do now is write a function that will get the maximum. So functions start off in Python. We define max. We're going to call it myMax because max is already a function in Python, and it's going to take in two numbers, a and b. If a is greater than b, return a. Means if a is larger than b, this function is going to evaluate to the a. Otherwise, else, return b. So this isn't perfect. If the numbers are equal, that we haven't really considered that case. But just for the simplicity's sake, we're going to say a and b are never going to be equal. So let's try and run this. Enter two numbers, 12 and 15, and it ends. Well, that's interesting. So what did we forget to do? Well, first of all, we didn't actually call this function, we just defined it. And second of all, we didn't actually print out any result. So what we're going to do is go down here, and we're going to say maximum equals max of x and y, or myMax. And then print maximum. So ideally we enter two numbers in, and we're going to get the max of both of them. So run it again. Enter two numbers, 12 and 15. 15 is our largest number. Great. Let's try it again. Let's do 102. Wow, 2 is not bigger than 100. What's going on here? Well, this is kind of one of the first problems with Python. When we were kind of going willy-nilly and changing that variable, we didn't really know what type it was. It could be a number, it could be a string, it could be a single character. For example, it could just be the character A. We don't really know what's in that, and that's what dynamically typed means. Statically typed, on the other hand, means that we're going to tell the computer exactly what type this variable is going to be, and it's going to stick to that unless we explicitly change it. So let's go ahead, and I will really quickly just write up the same equivalent max function over here, and I'll show you what I mean with types. So we're going to create a new function. You can see we have to tell it at the top that we're going to make a new function, return an integer. So it says int. We're going to call it max, and we have to define what types it takes in. So we're going to say int a, int b. Then down here at the bottom, we'll actually define the function. We'll say int max a, int b. And then inside this block, we can actually tell it what we want to do. We say if a is greater than b, return a, else return b. This is the same function that we had before over there in Python, but it's in C this time, and we've got our types down. So let's see if we can try and see how this works. We can ignore how I'm about to do this. It's not really applicable to Python. It's going to be a little bit weird, and this is going to be one of the examples that kind of shows why Python's going to be a little bit more simpler. So we're going to define int a and b both equal to 0, or we don't need to make them equal to anything. Print, enter two numbers, read them into the addresses of A and B, which once again we don't really need to know, and then we will print the large number is A and B. Let's run this. 12 and 15. Large number is 12. Oh, oops. Had a less than in there. Alright, 12 and 15. Larger number is 15. Try it again. 15, 12. Large number is 15. Great. So this one works, the other one doesn't. What's happening over here in Python is that we haven't actually, it's reading these in as strings. And so it's evaluating the string value and checking if, over here we can say, let's ask if the string value of 2 is greater than the string value of 100. It is. So what we need to do is cast these types. So over here in our function mymax, we're going to say A and B are going to be equal to int A, int B. Those int functions are going to cast and change those values. So over here, back in our interpreter, if we do 2, we'll get the string 2 back. But if we do int string 2, we get the number 2. See, there's no quotation marks around it, which means it's an integer. So now, if we run our program, which will take in a sec. Alright, so we enter two numbers, 2 and 100. 100 is the bigger number. Now it works. So in this tutorial, I showed you how to write a maximum function in both Python and C. And I showed you one of the examples of where Python is a little bit more flexible, sometimes to its detriment. Later on, I'll show you where this flexibility can really be powerful and can let you write programs and prototype ideas you have with very little overhead and very little work to do. Thanks.